Doing 8.1 perpendicular bisectors of triangles. And so just for a point of clarity, we're talking about the circumcenter here. And the circumcenter is labeled right here as point P, and that is where all of the perpendicular bisectors for each side intersect. And there's a unique property about this circumcenter. As it turns out, the circumcenter, once you have these perpendicular bisectors intersecting at point P, that point is actually equidistant from all of the vertices of the triangle. And so I made a little song, and it goes something like this. Perpendicular bisector, 1, 2, 3. These make the circumcenter just for me. Perpendicular bisector, A, B, C. The circumcenter is equidistant from these vertices. Yep, so that was the song. Okay, of note here that since the circumcenter is equidistant from the vertices, then we can draw a circle all the way around it, using the circumcenter as the center of a circle, and the circle will circumscribe that triangle. So it's called being circumscribed if you have a circle all the way around it. But let's go ahead and use that perpendicular bisector theorem to solve some problems. We have this one here. Again, we have a triangle, GHJ. Hey, Sam's going to join us here. So here's my triangle. I have HJG. I know that Z is the circumcenter because the perpendicular bisector is here, and it tells me. And then it gives us some values. It says that ZH, so Z to H is 85. M to Z is 13, so this is 13. HG is 136. HG is 136, and we need to find KG and ZJ. So we know what K is, right? It's the midpoint of HG. So KG is exactly what fraction of HG, Sam? 1/2. Good answer. Yep,
Yeah.
exactly one. Okay, so HG we know is 136. So then we can just calculate 1/2 of 136, which is.
If I had to
Go ahead, take your time.
I can do that.
When you figure it out, let us know. We'll move on.
Here,
Meantime, Z is, again, the circumcenter of triangle GHJ. So we have GHJ. So ZG, Z to G here, is going to be equal to ZH and ZJ. You can do it without a calculator.
No,
Sam,
I can't.
you divide 136 by 2. This is not... My
So
seventh grader, or my
It's
7-year-old can
point-
do it. It's
or
not point
70
anything. It comes out even.
73.
You got 73?
It's
Keep
68.
keep
Oh my
working
God,
on it.
It's 68.
Good job. Okay, so calculus students can do this. You guys can do this, I promise. All right, so finally, since all these are equal to each other, right? Since this is equidistant from all three vertices, remember the song? These guys are all equal to each other. They're all 85. Okay.
What's the song?
So let's go ahead and try this one. See if you can do 5. So pause here. Here's Sam's phone. Hopefully you got this. ZJ is 65. HJ is 2. HL is 2. All right. It's a little harder when we're in the coordinate plane. So we'll do an example here of being in the coordinate plane. Remember when we have a go ahead and we'll graph these points here. We'll figure these out. But the trick with this one is the perpendicular bisectors. So if we have a line, we have to be able to calculate what that perpendicular line is through a given point. And we should be able to do that, right? We have the skills for that. Here's my points. And then 5, -1. Okay, I guess I can label these. That was A. This one was B. So Sam, have you started figuring out what that blank is right there? So when I ask you, you'll have the answer.
Oh,
So it says, find the equations for 2 perpendicular bisectors. Since AB is,
6 points.
nope,
It's
it's going for orientation here. What's the slope of AB?
0.
So its perpendicular bisector is vertical. Yeah, so the slope is 0 or it's horizontal. That's fine. The perpendicular bisector of AB, therefore, is going to be a vertical line through what point? This point here. So we can go ahead and draw it. What? It's the line. What's the name of that line, Sam?
It's the midpoint.
No, just this line. What's if you were to graph that line? I'll give you a hint. It's x equals
Negative b plus or minus c squared.
You can graph things, right?
Oh.
X equals the black line.
2.
2. Yes, x equals 2. Good job. He's doing it.
Yes.
Okay. So side BC here, same sort of deal. Since BC is a vertical line, we want a horizontal line that goes through. Oh, I gave away the answer. I was going to quiz him again. Again, the midpoint is right there. Right? We can calculate midpoints. We can get oink. So these are our 2 lines for our 2 perpendicular bisectors. We could get the perpendicular bisector of AC. That would also work, but the math is a little bit harder there, right? Okay, so Sam, where do these 2 lines intersect?
They intersect at 2, 2.
Yeah, 2, 2. Cool. So 2, 2 is the circumcire. We can calculate that. Go ahead and try 8 and 9 real quick. I have a cool picture to show you. Let's go picture. Okay, and there's your answers. Oops. So that's it. That's all I got. Bye, goodbye.